Alright, in this video I'd like to talk about simplifying rational expressions. Alright, so let's talk about a rational expression first. A rational expression, also called an algebraic fraction, is a quotient of two polynomials. So here's some examples. 5 over 7. So all your fractions that you've talked about before, they are also called rational expressions because it's just a polynomial over a polynomial. 2 over x minus 1. You have the polynomial 2 over the polynomial x minus 1. You could also be more complicated polynomials like x squared minus 4x plus 4 all over, say 3x plus 7. So the idea is just a polynomial over another polynomial, right? So that's the entire idea of a rational expression. Now, make a note. A rational expression is undefined at any values that make the denominator equal to 0. Right? Because we're talking about fractions now. We don't want anything that makes the denominator 0, right? Because a fraction where the denominator is 0 is undefined. Right? So what about x plus 1 over x minus 5? What values for x would make this rational expression undefined? Well, the way I'm going to recommend you do that is you're only worried about the denominator in this particular case, right? So take the denominator, x minus 5, set that equal to 0, and solve for x. Alright, so I'm sure you saw that 5 made the denominator equal to 0 right off the bat, but it's the idea here that take the denominator, set the denominator equal to 0, solve for x, and then that number or numbers that you get after solving that equation for x, those are the numbers that make your rational expression undefined. In this case, 5 is the only number that makes the rational expression undefined. All the other real numbers are okay. Right? What about, say, this one? Right, so you have x minus 7 over x squared minus x minus 6. This one's not so easy to see what makes the denominator 0, right? So take the denominator, set it equal to 0. Right, now we've got a little equation to solve. And we can factor this left-hand side here, right? That goes into factors. The factors of 6 that subtract up to 1. That would be 2 and 3. So we need x2, x3. This is a minus 3 and a plus 2. Right? So now we set each factor equal to 0. You'd have x plus 2 equals 0, x minus 3 equals 0. So x equals negative 2 or x equals 3. If x is either one of these numbers, negative 2 or 3, then our rational expression up here is undefined. All the other numbers are fine, right? But negative 2 and 3 make our denominator equal to 0. Everybody understand that? Because that's the idea on finding out what makes a rational expression undefined. You're just trying to figure out what numbers that make the denominator 0. Now, I'd like to talk about simplifying rational expressions. Right, so here's our first example. Alright, so this is something you should have seen before, right? This is just a rational expression of a monomial divided by a monomial, and we've already solved these back with properties of exponents, right? You've got 6, 12, x to the 5th over x, so that would be x to the 4th in the top. 6 and 12 reduces down to 1/2, so you have x to the 4th over 2 is what this simplifies down to. Now that's just a refresher of stuff we've done before. Now what about number 2? Alright, so 4a minus 12 over 4a. Now, the most common error made is the 4a's go away and you're just left with negative 12. Right? That is the most common error made. But we cannot do that. You just don't cancel those 4a's out. Right? You've got to think of it this way. Think of if you had 2 plus 3 divided by 2. Right? Can we just cancel those 2's out and just be left with 3? Right? Does that equal 3? No, because following the order of operations, we need to do 2 plus 3 first. That gives us 5, right, over 2. And then 5 over 2 is just 5 over 2. Right? As opposed to, say, what if it was 2 times 3 over 2? Right? Now can we cancel these 2's out and be left with 3? Right? Let's see. If you cancel the 2's out and are left with 3, I'll write it this way. Right? Cancel that, you get 3. But following the order of operations, you'd have 6 divided by 2, and 6 divided by 2 is equal to 3, right? So yeah, this works when it's multiplication, right? When you have 2 times 3 divided by 2, then those 2's can divide out, and what they do is they divide out to 1. That's really what that means, right? 2 times 3 divided by 2 is the same thing as 2 over 2 times 3, and the 2 over 2 goes to 1, and 1 times 3 is just 3. Right, that's the mathematics that's really happening. We don't get to do that when it's plus. 2 plus 3 divided by 2 is just going to be 5 over 2, and that's all we can do. There's no canceling those twos out. All right, that's a very common error, so be very, very careful. All right, so now back to our problem. All right, so since we just figured out we cannot just cancel the 4a's out and be left with negative 12, the concept that we want to make very clear here, the concept that we want to do is factor the numerator and factor the denominator. All right, so in this case, you look at 4a minus 12, and we say, all right, how do we factor that? Well, we can take a 4 out of that, right? So you'd have 4 times a minus 3. And the denominator is 4a, so that just is 4a. It's already factored, right? 4 times a. There's nothing else you can do with that. And now everything is in terms of multiplication and division. And now we can see, right, that, well, we've got 4 over 4, so that goes down to 1, right? And we're left with a minus 3 in the numerator all over a in the denominator. Right? It's because we've got this multiplication. Remember, you can rewrite this now as 4 over 4 times a minus 3 over a. Right? And the 4 over 4 goes down to 1. Everybody see that? All right, so the concept is, before you divide anything out, make sure you have the numerator and denominator completely factored. All right, so let's try another one. All right, so let's factor the numerator. So that's x squared minus 4. That's the difference of two squares. So we can rewrite that as x minus 2x plus 2. The denominator, you have x squared plus 5x plus 6. There's a trinomial, leading coefficients of 1. So factors of 6 that add up to 5. That would be 2 and 3. Everything's plus, so x plus 2, x plus 3. Right, everybody see that? And then we look to see, all right, are there any factors that are common to both the numerator and the denominator? And we can see that x plus 2 is, right? That those two things divide out to 1, leaving behind x minus 2 divided by x plus 3. All right, everybody see that? Okay, let's do one more. All right, so we have x minus 3 divided by 3 minus x. All right, I brought this one up because I want us to see that, well, they're not the same, right? X minus 3 is not the same thing as 3 minus x, but they sure do look an awful lot alike, right? They look really, really close to being the same. Right, remember we talked about before, we can factor a 1 or a negative 1 out of really anything that we want. So in this case, we see that they're opposites of each other, right? So 3 minus x, we could write 3 minus x by factoring negative 1 out, right? So let's leave the numerator alone. Let's take the denominator negative 1, 3 plus x now. Everybody see that? Right, if you factor negative 1 out, you get negative 3 plus x. But notice now then that we can rewrite that denominator as x minus 3. You see that? Negative 3 plus x is the same thing as x minus 3. And now the x minus 3's, right, can divide out. The whole thing can divide out, leaving behind what? Negative 1. Right? So this expression, x minus 3 divided by 3 minus x, that divides out to negative 1. And this is because x minus 3 and 3 minus x are opposites of each other. Right? In fact, whenever you see that, a minus b divided by b minus a, that is always going to go down to negative 1. Always. And this is the mathematics of y, because you can factor a negative 1 out of one of the two things. It doesn't really matter. And make it look like the other one, and divide out the common factors, and you're left with a negative 1 behind. So the main concept here is example 3, where we've got polynomial divided by a polynomial, and the plan of attack is completely factor the numerator, completely factor the denominator, and then divide out any factors that are common to both the numerator and the denominator. All right, that's it. Study well. Please let me know if you have any questions.